Right, so last time we solved triangles, we were looking at law of sines. Okay, we saw that law of sines is used for three types: your angle side, side angle, or side angle. Okay, side angle, you got to be careful. That's the one where you could have the 0, 1, or 2 solutions. Okay, but there's two other types that we haven't talked about yet. And that's side angle side and side. So there's a diagram of what each of those would look like. Okay. When you have side angle side, you've got two sides and the angle included between them. And then side, you have all three sides. Now, they could be tricky on side, and it is possible they give you a no solution case. You could never have two solutions. But I was just thinking, there is a way it could be no solution. Anybody remember the relationships? It's an inequality between the sides in a triangle. What has to happen if you've got three sides, like if I just name three random numbers, and you want to know if those sides make a triangle? What has to be true?
The sum of any two has to be greater than the third.
Right. If you add any two together, it's got to be bigger than the third. If that doesn't happen, then you don't have a triangle. So like if I gave you sides of 2, 3, and 10, you can't make a triangle with 2, 3, and 10. Because if you add 2 and 3 together, it's not bigger than 10. And it couldn't even equal 10. Okay, it's got to be bigger. So like if you had sides of 5, 5, and 10, nope, that will not make a triangle. Any two sides added together have to be bigger than the third. That's for any type of triangle, any triangle you can think of. Right, so any questions on the types that you're going to use law of cosines for versus the type we use law of sines for? Okay, on the next test, I'm going to throw in some of the law of sines, so then you're going to have to pick, is it a law of sines or law of cosines problem? I've already tested you on the multiple solution case, so most likely I'll pick one that just has one solution for law of sines rather than multiple. Okay. All right, let's take a look at this. Right, like the law of sines, there's three different versions of the law of cosines. Okay? Well, actually, with law of sines, it was like there were three parts: sine of alpha over A, sine of beta over B, sine of gamma over C. Well, we're going to have three separate equations here. And the equation that we're going to use depends on the information you're given. All right, so let's see if we can figure out the law of sines. Okay, what I've done is I've drawn a triangle with sides A, B, C. Okay, put alpha across from A, put beta across from B, and I put gamma across from C. Okay, I also drew in an altitude. This altitude doesn't necessarily bisect side B. And because I've drawn in that altitude, I have two right triangles. What theorem are you allowed to use if you have a right triangle? Has to do with the sides. Yeah?
Pythagorean theorem.
Yep. We can use the Pythagorean theorem. So what I want to try to do is use the Pythagorean theorem on this right triangle. This one right here. All right, so I know one of the sides is C. So let's plug that in. So C squared equals. Now I've got to find each leg. Let's start with the height. Okay, we're going to write the height using gamma, A, and Y. All right? We're going to use a trig function to figure out what Y is. Which trig function would involve gamma, A, and Y? So first look at Do you have opposite, adjacent, hypotenuse? Which two out of the three? And then think which trig function has those in it. Okay, Andrew, what's one side we have here relative to gamma?
The opposite.
Yep, we got opposite. And what about side A?
The adjacent.
Well,
To gamma.
it's across from the 90.
Yeah. So it's on top.
Hypotenuse, good. So we got opposite, we've got hypotenuse. Sylvia, what trig function is that? Opposite and hypotenuse?
Sine.
Sine. Okay. So off to the side, I'm just going to write down sine of gamma equals opposite over hypotenuse, y over a. And then I'm going to solve that for y by moving a to the other side. And Justin, how would I move a to the other side? Good. Multiply both sides by a. Right, so there's my height. Right? So Pythagorean theorem says you take the hypotenuse squared, take the other leg squared, which I now have. It's a sine gamma squared. Now we're going to do the same thing one more time. We're going to find the bottom side. Now, what's the entire length of this bottom side? Yeah,
B.
it's B. So if I can basically take B and subtract something away from it, which I'm labeling as X, then I'll be left with just that part that's in red on the bottom. So we're going to take the whole thing, we're going to subtract away something, and be left with what we want. Now the key we got to find, this time we're going to use gamma. Let's see. I'm going to use X and A. Which trig function would involve the three things I just circled in blue? Oh, Orlando? What's the name of side X relative to gamma? Adjacent, and A is the hypotenuse. So you remember which trig function has adjacent and hypotenuse? Cosine, good. Okay, so off to the side again, this is just kind of our scrap work. Cosine of gamma equals adjacent over hypotenuse. We're going to do the same thing Justin just told us last time to get A on the other side. Now we've got a formula for X. And the whole reason I did that is because I wanted a formula for X and Y, both using A and gamma. Okay, they both use A and gamma. Right, so now we're going to take that part, subtract it away from B, and we'll be left with the part we want. And square it. Okay, once we do that out, that's going to give us the law of cosines. So let's see what we get. C squared. Remember, when you square a product, you square each individual factor. So it's a squared sine squared gamma. Now this part, because it has a subtraction in it, you have to FOIL. That's the only way to do that part out. Okay, so if you need to see it visually, it's like you're foiling this. Okay, so when I start to foil it, Brian, what's B times B?
B squared.
B squared. Okay, Marina, what's B times negative A cosine gamma? And then another B times negative A cosine gamma.
-2.
Yeah?
Would it be B, A?
Yeah, we'll do it in alphabetical order. So negative 2AB,
Cosine gamma.
good, cosine gamma. And then the last part, negative A cosine gamma times negative A cosine gamma. Well, negative times negative is positive. A times A is A squared. And cosine times cosine is cosine squared. Okay, so it kind of looks a little bit worse, but some things are about to cancel out. I'm going to regroup these a squared terms and put them next to each other. And I'll do it in two separate steps. Sine squared plus a squared cosine squared. So I put the first and the last term next to each other. Now I'll put the rest of it. B squared 2ab cosine gamma. Anybody see something I can do with just these first two terms? Yep.
Sine squared plus cosine squared is 1.
Well, that's true. We are going to, how can I end up with sine squared plus cosine squared here? What do I have to do?
You'd have to divide everything by a squared to get them along, but that would probably just make it worse.
Yeah, it would make this part worse, but how about if we just factor it out from the first two? Just factor an a squared out from them. And you're left with this. Sine squared plus cosine squared. A squared has been factored out from both. And leave the rest of it. The rest of it is going to be part of the final formula. That's not going to change. And Sam, what did you just say a sine squared plus cosine squared was?
1.
1. So this all becomes a 1. So we have a squared times 1, which is just a squared. So we get c squared equals a squared plus b squared minus 2ab cosine gamma. And if you just look at the first part of that formula, what does it kind of look like? Yeah. Yeah, it's the Pythagorean theorem. Okay, the difference is this part that you're subtracting on the end, this minus 2ab cosine gamma. Well, normally we don't see this part when we write the Pythagorean theorem. Okay, when you can use the Pythagorean theorem, what kind of angle does gamma have to be if it was the Pythagorean theorem? Well, Michael?
90?
Yeah, this would have to be a 90. Well, watch what happens if you take the cosine of 90. Or does anybody already know? It's 0. So if you try to use this formula on a right triangle, you plug in cosine 90 and you get 0 times 2ab. Well, it doesn't matter what a and b are. It'd be 2 times a times b times 0. This whole part would disappear, and you'd be left with just the Pythagorean theorem. C squared equals a squared plus b squared. But if your angle isn't 90, this part isn't 0. Okay? And that's what it's going to be for us today. It'll be something usually that's not 0. Right? There's 3 versions of this law. They're all very similar. Okay, based on the pattern up above, I'm not going to prove it 3 more times, but based on the pattern, anybody think they can tell me what the second one would be, or at least what would come next? B squared equals what?
A squared plus c squared.
A squared plus c squared.
Then would it be minus 2ac cosine beta?
Yes, cosine beta. Right, so the pattern is you take one letter squared, it equals the sum of the other 2 squared, minus twice the product of the 2 you just used before it, a and c, times the cosine of the angle that's across from the letter you started with. Sometimes it helps to remember the general idea if you've got a diagram, and they don't label it with A, B, C. So you don't get stuck into always thinking, where's A, B, and C. Okay, and let's look at the last version. Okay, Shannon, what do you think comes after the A squared?
B squared plus C squared
Yep, B squared plus C squared.
minus 2BC
Yep, minus 2BC.
alpha.
Cosine of the angle across from the letter we started with, which was alpha. Okay, so there's all 3 versions of the law of cosines. Notice all three versions have all three sides in them. Every version has A, B, and C. So when you're using it, if you're missing two sides, okay, that would be a problem here. All right, if you're missing A and you're missing C, okay, you couldn't use the second version, okay, or the first version or the last version. They all have A and C in them. So that would probably be more of a law of sines problem, okay, if you're missing two sides. Okay, remember, this is only used for side angle side, in which case you're only missing one side, and side, 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 in which case you're missing none of the sides. Right, so you cannot use law of cosines if you're missing two sides. All right, so let's try a few problems, see what we can do. So in this case, they told us A is 4, B is 7, and gamma is 42. Okay, Carly, what do you think a good first step would be?
Maybe drawing a diagram.
Yeah, why don't we make a diagram just so we can see the relationship, what's where? Because if you're not sure how to look at this table and figure out if it's law of cosines or law of sines, that's what a diagram will help. Okay, so let's make a diagram. Again, this is not to scale. Just maintain those relationships, A across from alpha, B across from beta, and so on. So if A is there, alpha is there. We put B at the bottom, which actually, you know what? We know B. B is 7. Beta is at the top. That would be C. And gamma would be across. So it's side, angle, side. Okay. Side, angle, side is one of the two types that I said, yeah, you're going to go ahead and use law of cosines. Now, with side, angle, side, you are pretty much locked into using a certain law first, or a certain version of it. Let's go back and look at them. So, which version do I have to use here right away? Version 1, 2, or 3? And why?
1, because you don't know c squared, so you're solving for it easily. I mean,
Okay, so yeah, we got to use the first one because we're solving for c. Not just because c squared is by itself, but what's another reason I have to use the first one? Like what would happen if I tried to use the second or third one? Yeah.
we have a gamma, so we need to use c, we don't have the other angles.
We've got gamma, we've got to use it. Okay? If you try to use the second or third one, you're going to be missing c, and you're going to be missing the angle. You don't have alpha or beta. So you've got to use the first one. All right, so let's set it up. So c squared equals a squared plus b squared minus 2 ab. And some of that you might do in your head. And as we go, we'll do some of it. But first time through, I'll just show you every step. Cosine of gamma. All right, so let's go through and do that. So we get c squared equals 4 squared is 16. 7 squared gives me 49. What's 2 times 4 times 7? Right? 56. Cosine 42. Okay, from here I'm going to follow my PEMDAS, which is, doing your multiplication always before we do addition and subtraction. We could add the 16 and 49 because that's not going to be affected, but what you wouldn't want to do is do 16 plus 49 and then take away 56 because the 56 is multiplied. So let's just handle that first so we don't make that mistake. Check your calculator. For this section, I think most problems are degrees, so just switch that over. And type in 56 times cosine 42. So we get 41.62. Now just finish it up. So 16 plus 49. So you get 23.38. Remember, that's not c, that's c squared. So what's my last step? Get c by itself. Yeah,
Take the square root.
take the square root. And let's square root of 23.38. It's about 4.84. And that's c. Okay. Any question on that? All right, so law of cosines, very clean, very easy to use formula. You just have to make sure you follow order of operations, and that'll become more important in the next one too. All right, so now we know c. Okay, this side is 4.84. Instead of just being a side angle side triangle, side angle side, that's the original. What other kind of triangle is it now? Yep.
Side, side, side.
It is a side, 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 which we would still use law of cosines for. And what other way could you view this triangle? Yeah, you could. You could look at it as a side, side angle, which would be a law of sines problem. The problem with looking at it as a law of sines problem, what can happen in the side, side angle case?
You can have 0, 1, or 2 answers.
Right. You got to deal with all that 0, 1, or 2 answer case. Okay. Well, if we want to avoid that, not have to worry about it, we just use law of cosines one more time. And then we don't even have to worry about all that other stuff with law of sines. All right, so that's my suggestion. Finish this up as a law of cosines problem. All right, so let's find, you could do alpha or beta. It doesn't matter since you know all the sides now. But you do have to use c to find alpha. So if you got c wrong, alpha comes out wrong too. Right. How does the law of cosines start out to find alpha? Julia? How does that come on start?
A squared.
Yep. And if you can remember, it starts with a squared. Everything else kind of falls into place. You know, let's write it in as we go. So we got a squared equals b squared plus c squared. Okay, b squared plus, well, I already had c squared from the previous problem. 23.38. Okay, so just use that. Or if that, that might actually confuse some people. I'll write c squared, and I'll square it in the next step. Okay, so a squared equals b squared plus c squared minus 2 times b times c. So 2 times 7 times 4.84. I'm going to use parentheses there. I think the dot for multiplication with the decimal, it's going to look a little confusing. So 2, okay, and then cosine of the angle we're looking for with alpha. Okay, now you just have to go through this very, very carefully with your arithmetic. Okay, 4.84 squared, we already know. It's 23.38. Minus 2 times 7 is 14 times 4.84. Anybody have that? 14 times 4.84? Just to 2 decimals?
67.76.
Thank you. Okay, what would I do next there?
find like terms, so you can combine 49 and 23.38 because it's not going to affect the 67.76 multiplied by cosine alpha.
Okay, so let's combine 49 plus 23.38. You can get 72.38. Okay, now what's my next step? Yeah, Cassie.
Subtract 72.38 from both sides.
Yes. Why not do 72.38 minus 67.76?
Because it's going to do cosine multiplication.
Right. You can't subtract the 72 and the 67. They're not like terms. This equation is basically like solving this. You have a number equals a number minus another number times a variable. Okay? You could not do 72 minus 67 now because they're not like terms. Right, so that's perfect. A lot of people, they usually fall for that trick. They look at it and they're like, oh, 72 minus 67, we'll just do that. But that was perfect. Exactly what she just said. So that cancels. Now we've got 16 minus 72.38. Oops, 16. So you get negative 56.38 equals negative 67.76 cosine alpha. Okay, Lasan, what's my next step?
Divide by 67.76.
One more time, divide by what?
Negative 67.76.
Yeah, divide by negative 67.76. So that's going to cancel that. It's going to cancel your negatives, and it's going to cancel the negative there as well. All right, so let's see what we get. So 56.38 divided by 67.76. And it's good that that number came out less than 1, because if it didn't, we'd have a problem. Okay? Whenever you have a number equal to cosine or sine, it's got to equal something between negative 1 and 1. Okay, so we get 0.83. And my last step, to get rid of cosine, do inverse cosine on each side. Now you don't have to worry about looking for a second answer. As I told you, this was the type that only had one solution. Okay, so it's 33.90. That's all. Okay, you don't have to worry about the second solution, because the only other quadrant where cosine comes out to a positive angle, you'd never have a negative angle in a triangle, would be quadrant 4. All the angles in quadrant 4 are way too big to fit in a triangle. They're all between 270 and 360. So there's no way you could have a second answer in that quadrant. All right, so you don't have to worry about it. And now the last step, well, you can do it two ways. You can do what we just did again to find beta, or if you're confident you got alpha right, add them up and subtract from 180 to get beta. Everything in the law of cosines builds on it. So once you find one thing, you use that to find everything else. So if we made a mistake with C, we already have alpha wrong anyway. So, but it's up to you. If you want to go back and do law of cosines one more time, you can. I'm just going to add up and subtract from 180. So minus 33.9 minus 42. And we get 104.1. Okay, and that's a law of cosines problem. So it's straight algebra and arithmetic. That's all there is to it. Any questions on that? I think I'm just going to do one of each type. So that's the side angle side type. Let's look at side, side, side. Okay, so this is an example of side, side, side. And side, 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 I don't really think you need a diagram to tell. It's pretty obvious. You have all the sides. If you're given all the sides, which angle do you have to find first? Yeah.
It doesn't matter because you're all sides.
Yeah, it doesn't matter. If you've got all the sides, you can plug into any version of the law of cosines that you want. Okay? So if you, most people just find alpha and then they find beta. So we'll do law of cosines. Let's just do it once. I'll leave the second time for you because I want to look at a couple word problems, but we'll just go through at least one with the side, side, side. Let's find alpha. Actually, you know what? Did we find alpha in the last one? First, yeah, let's do beta then. Just it's not any harder, but just to try something different. Brandon, how does the law of cosines start out to find beta?
B squared?
Yeah, let's just write it down. So we have it. And you're going to fill in every side. Okay, and let's do some of it as we go. So b squared is 49. A squared is 81. C squared is 25. What's 81 plus 25?
106.
106. Minus 2 times A times C. So 2 times, let's do it this way, it's easier. 2 times C is 10. 10 times 9, 90. Okay, cosine beta. So if you do some of those steps in your head, you really shorten it up quite a bit. At least what you have to write down. Okay, next step, we're going to bring the 106 to the other side. Be careful you don't subtract the 90. You can't do that because 90 is multiplied by something you don't know. And when you're solving an equation, always move things to the other side using addition and subtraction, and then you divide last. Okay, division is always the last step. So let's subtract to the other side. So 49 minus 106. And then this last step is going to get cosine by itself. Then we'll get rid of cosine using inverse cosine. So divide by negative 90. Those negatives are gone. If you want, just leave it as 57 over 90. You don't even need to do that out. And actually, that'll keep your answer a little bit more accurate because we're not rounding anything off. Okay, and what I say the last step was to get rid of cosine? Yeah. Inverse cosine. Again, you're hoping for a number less than 1. Obviously, we have that here. The denominator is bigger than the numerator. Let's see what beta comes out to. So second inverse cosine, 57 over 90. So you get 50.70. Okay, any question on how we got beta? Okay, now you do the same thing one more time. Either find alpha or gamma, and then once you get 2 of them, then you can add up and subtract from 180. If you want to be really sure, you could find all three answers separate here, because you know all the sides. So in that case, you could actually make a mistake on one part and be okay on the other parts, if you found all three answers separate. Okay, any question, or did anybody get something different than that? Okay. All right, everyone feel like they could do it one more time on their own to get alpha or gamma? Seems okay. And that's the side case. Okay, that. All right. So using the law of cosines, we can come up with a formula that gives us the area of a triangle. Okay. Now your normal area of a triangle formula is based on doing 1/2 the base times the height, which works great as long as you know the base and you know the height. Well, using the law of cosines, we can come up with that formula for the area of a triangle. For this one, I am not going to go through the proof. If you want to see it, it is in the book, but we're going to hold off on the proof. Okay, and there's 3 versions of this, just like there's 3 versions of law of cosines, depending on which angle you know. The important thing to just try to remember is to find the area of a triangle. It's 1/2 the product of 2 sides times the sine of the angle between those 2 sides. So it's either 1/2 BC sine alpha, 1/2 AB sine gamma, or 1/2 AC sine beta. Just depends on what you know. But it's just half the product of 2 sides times the sine of the angle between them. That's what I just said. And the proof of that, it's on page 439 and 440. It's a very short proof. We're just not going to go through it. So here's a typical problem you might see. Find the area of that triangle. Now I haven't labeled the sides A, B, and C, so really just use the general idea. Half the product of 2 sides times the sine of the angle between them. Right, so what would that look like when I set up that formula for this problem? It would be area equals, yeah, Lasan?
3 times 12, I mean 1/2, 3 times 12.
1/2 times 3 times 12, yeah. Sine 105. And I know it seems a little strange just to do that without kind of knowing why. That's where the proof would come in. But you'll just have to trust me that that is the formula. Okay, so I do 3 times 12, it gives me 36. Half of 36 is 18. And then just do 18 sine 105. So the area of that triangle is 17.39. Okay, I put square units on the end because I don't know what the units are, but it is an area, so it should be labeled as square units. Okay, any question on finding the area of a triangle given 2 sides and an angle? It's kind of like law of cosines. Side, angle, side. And in fact, if you didn't remember this formula, you could go through and find other information here, solve this triangle, and maybe you could figure out what the height actually is. It'd be more work to do it that way, but you could. You could find that height. You could also work backwards and find the height now that you know the area. Use your basic formula, Area is half base times height. Well, you know the base is 12. You know the area. You could solve for the height that way too. Any other case for area of a triangle? Well, the other case you could have is when they give you all the sides. Okay, just like in the other version of other type of example for law of cosines. This proof is in the book. It's relatively complicated to go through. So even if we had time, this isn't a proof that I would do. And this is called Heron's formula. And it gives you a formula for the area. It's the square root of s times s minus a times s minus b times s minus c. Well, we know what a, b, and c are. Those are the sides. Okay, but s is half of all the sides added together. If you have a triangle and you add all the sides up, what is that called? Yeah? It's the perimeter. Well, if you take half of it, you get what's called the semi-perimeter. That's all S is. So S is the semi-perimeter. I usually find that right away. Get your semi-perimeter, and then fill into your formula. Right, so if you had a problem like that, 9, 7, and 5, be kind of a pain to use area equals 1/2 base times height, because we don't know if one of those numbers is the base and one of them is the height. Might not be. Well, actually, one of them could definitely be the base, but unless we knew the other one was perpendicular, we don't know the other one's the height. The previous formula I gave you, 1/2 the product of the two sides times the sine of the angle between them. Well, you could do it that way. 9, 7, 5. You'd have to use law of cosines. Solve for that angle, and then you could use the other formula. But this formula makes it even easier. You don't need the angle at all. Just use that formula. Let's start with our semi-perimeter. What's the perimeter of that triangle? What's 9 plus 7 plus 5? Shannon? 21. And then if you take half of it, you get 10.5. So there's your semi-perimeter. There's A, B, and C. Just fill it into the formula. That's it. Area equals square root of S. And it doesn't even matter if you know which side is which. It's S minus every side. So just do 10.5 minus 9 times 10.5 minus 7 times 10.5 minus 5. Okay, these I think we can do in our head till we have to multiply them. Taylor, what's 10.5 minus 9?
1.5.
Yep, 1.5. 10.5 minus 7. Sylvia? Good, 3.5. And 10.5 take away 5. That's 5.5. Now we do 10.5 times 1.5 times 3.5 times 5.5. So you get 303.1875. And don't forget to take the square root. So 17.41. Okay. Any question on that? It's just another way to find the area of a triangle. Okay, and the last one, it's a word problem. Let's just see if we can get the diagram, and then I'll leave solving it for you. Okay, so it says a surveyor wants to find the distance between 2 points, A and B, on opposite sides of a building. Okay, the surveyor locates a point C that's 110 feet from point A and 160 from point B. He wants us to find the distance between A and B. Now, maybe in real life, maybe there's a river between these 2 points, or maybe it's like a canyon and they're trying to measure across it. Well, if they can walk to each side of the canyon and figure out how far away they are from point A and B, and then measure the angle between the two, it makes finding this distance very easy. What kind of triangle is that? Silvio? Yep, this is side angle side. Let's call the distance, you want to find x. So you set it up. One side squared equals the sum of the other two squared minus twice the product of the other two times the cosine of the angle that's across from the side you started with. Solve that, and you'll know x. And x is by itself, so there's no algebra here. It's just arithmetic, take a square root at the end. Okay, so I'll leave simplifying all that for you. Okay, but that's the basic idea. When you're given a word problem, try to, like always, make a triangle out of it, and it'll either be side angle side or side 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 in tonight's homework. That one we're going to skip over for now. I'll show you how you can use the law of cosines to find where two lines cross. Not an overly important application, so if you get stuck on that one, don't worry about it. In fact, I don't even think I gave you one of those in the homework. So on 443, it's 1, 2, 5, 6, 13, 14, and 17 through 20.